in between. Similarly, something is eaten by Devadatta. So in between, this fiery is there. So you cannot understand the meaning. So what they say is, if there is such a gap or intervention, then there is no proximity and you will find it difficult to understand a sentence. So mathematically, I can say that if I have sentences and I show which word is related to which word by these edges, if there are no crossings, if it is a planar graph, then that means the sentence is good. But if there are such crossings, then the sentence is very difficult to understand, or it might be unmeaningful as well. So we get this efficient engineering design. We know what are the parameters, or we know how to model the constraints, how to model this condition mathematically, and then this can be taught to machine, and machine can then decide whether some sentence is meaningful or not. Okay, so when is a sentence with non-planar graph grammatical and when it is ungrammatical? So actually what has happened is, though I said that if there are such crossings, the sentence is ungrammatical, we found many examples in Sanskrit where such crossings were there. And again, we found some clue from Indian theories only. And what the Indian theories about the expectancies they say is, when you listen to something, two types of expectancies rise in your mind. So if I say go, immediately, or go, if I say goes, immediately a question rises in my mind: who goes and where does he go? These are called Utthita Akanksha. And then there are other kinds of Akanksha's. If I say Pustakam, Ramasya Pustakam, the book, Rama's book. If I say Rama's, then there is an expectancy of book. But if I just say, bring the book, bring that book, then the Rama is not necessary to say. Okay. But the moment I say Rama's, immediately I need some noun which qualifies Rama, or which satisfies the expectancy of Rama's book, Rama's say clothes, or Rama's wife, some relative word which is related to Rama is expected there. This is called Uttapya Akanksha, or it has a capability to raise an expectancy. So there are these two types of expectancies, and what we found was, this type of expectancy, Utthita, these words which have, both the words have expectancies, they are always together. But if only one word has expectancy, like Rama's, and book does not have an expectancy for Rama, they may get separated. And this is what we found in the experiments we did. So among these two expectancies, the mutual expectancies, they are always together, like in your molecules. When you have the sharing of the electrons, then they are always together. One attracts the other one which does not have the extra electron, which needs an electron, and the other one has extra electron. Both of them, they join together to make a compound, like in H2O or sodium chloride, NaCl, etc. But if the electrons are very far away, then they will not have any extra, I mean, they will not be that powerful enough. So they can then, they are little, yes, they have expectancy, they want to join, but sometimes they would also be freely floating little away from the central nucleus. So we have such words, such suffixes like the genitive Rama's book, or adjectives, they can go little far away, etc. So this again gave us some insight into how to develop the parser. So actually we did some experiments, empirical studies, and we found that whenever there is mutual expectancies, there is tight coupling, but words with unilateral expectancy, they may move around. Okay. Then there is a concept of, so again, I'm skipping one thing and I will directly go to one more example of design, engineering design. See, now suppose I want to develop a computational tool to which I give one sentence or one verse in Sanskrit, and machine should be able to give me a kind of analysis of the sentence. Okay. So what are the steps that are involved? How should I proceed? What modules I should build? So there is again a commentary tradition in India, and the criteria or the definition of a commentary. They say that commentary should have these 5 components. First one is padacheda, that means segmentation. So given a sentence, first you should segment it. After segmentation, you should provide the analysis of every word and its meaning. Then you should provide the paraphrase of the compound words, and then you should provide the sentential meaning, or you should arrange the words in such a way that you can get normally prose. We know that the poetries are very difficult to understand, so we try to convert those poetries into prose. So it says that you should analyze, you should arrange the words of the poetry in a prose form. And then there is one more condition, that if earlier commentators have raised some objections, then you should answer those objections also. So these 4 things, first 4 things, have given me a clue how to develop these computational tools so that you can process a Sanskrit text. So first you build a segmenter which will segment, which will cut the words, the sentence into words, then analyze every word. If there are compound words, analyze them, and then you arrange all these in such a form that you understand the complete sentence. So I will give you one example before concluding my talk. So let me see where it is. Yeah. So I'm going to my website where it is a machine translation system from Sanskrit to Hindi. And I have given, I'm sorry, I have written this in Devanagari. I hope some of you at least can understand this. The shloka is from Ramayana. Tena Mayavina Duram Apavahya Nrupam Jahara Bharyam Ramasya Grudram Hatva Jatayusham. So this sentence, this shloka, I give to machine. Okay, I submit here. Now machine will try to analyze this shloka and produce in front of you some graph Through that graph, you should be able to understand this shloka. So it has analyzed the shloka and it says, Jahara is the verb. Jahara means to steal. Okay. Then naturally we have a question, who has stolen and whom? Okay. So here you have Bharyam. Bharya is wife. Again you have an expectancy. Whose wife? Rama's wife. So Rama's wife was stolen. I'm using very simple words. Okay. Grudram is also there, but this is something machine has failed here. I will come back to this. When did he stole? After killing Jatayusha, which is a Grudra. So this Grudra should come here. Okay. The bird Jatayusha was killed. After killing Jatayusha, he abducted Rama's wife. But before that, he also did something else. Apavahya means taking somebody far away. So Duram, far away. Taking somebody far away. Whom? Nrupam. So it is Lakshmana or Rama. Taking Rama and Lakshmana far away. But by whom? By the Mayavi Maricha. So with the help of Mayavi, taking Nrupam far away, after killing Jatayusha, it's not mentioned who he is, we know it is Ravana. Ravana took Rama's wife. He flew with her. So this is the sentence, and we get, except this one relation where Grudram is marked as karma, Grudram should be joined with Jatayusham. Otherwise, this complete sentence has given, the shloka is analyzed by machine correctly. So how it could do this? Because what machine did was, first it analyzed the every word, providing the analysis of every word, that this is in third case masculine singular. Okay, this one is a causative which is an indeclinable, and the verbal root is prefix is upper and the verb is vaha, etc. So for each word, it gives the word analysis, and after the word analysis, it tries to show how the words might be related. And thus, we will be in a position to understand the original shloka, and then we can make a prose out of it and understand the sentence, etc., which is called the anvaya. Again, I'm not going in those details, technical details. So coming back to this, just let me conclude. Indian theories of language analysis and generation, that is Panini's grammar, as well as the theories of verbal cognition, they provide a sound base for building computational linguistic tools. Indian grammatical theories also provide the necessary knowledge base to decide what is feasible and what is not, and that we have seen earlier. And finally, they help us in efficient engineering design.